continue talking about contingency tables and discuss marginal and conditional distribution. So remember that a contingency table shows two categorical variables within one table. Here we have the ticket class for passengers on the Titanic and their survival, whether or not they were alive or dead after the Titanic sank. The totals in the bottom and far right are our margins and give us the frequency distribution for each variable. When we use the margins, we call it marginal distribution because we're using the margins. So we can find the marginal distribution of survival. So here you go to survival, which is alive and dead, and then you go over to the totals and take 711 and divide it by 2,201. So the total number that were alive divided by the total number of passengers. Then we would look at the total number of people who died when the Titanic sank, which is 1,490, and we would divide that by the total number of passengers, 2,201. Those two percentages would then give us our marginal distribution. Values that are inside the table are called cells. The cells show us how the two variables are combined. So, for example, we can see in the table, with the number that is circled, that 673 crew members died when the Titanic sank. We use the cells in the table to find what is called conditional distribution, because those values will give us something that is contingent or based on another variable. So, for example, we can find the conditional distribution of ticket class, where the condition is that they have survived. So here, what you do is we only look at the people who have survived. And then to find the distribution of ticket class, we take those, the ticket class passengers, so first class passengers, we have 203 that survived, and we would divide that by the total number of passengers that survived, the 711. And this gives us the 28.6% of first class passengers out of all that survived. Then we can see by taking 118 and dividing it by 711 that of all of the passengers that survived, 16.6% of them were second class passengers. Of the passengers that survived, 25% were third class passengers, and of those that survived, 29.8% were crew members. These are also called row percentages because you're using the row. Row percentages, when you go across in row, should add up to be 100%. You could do the same thing if you were going down in columns. Those would be called column percentages, and then all the percents in the columns should add up to 100%. So this is showing the conditional distribution of ticket class, where the condition is now that they have died. Again, they're found the same way. We only look at the total number of people that died, and we take our 122 first-class passengers that died and divide that by the total number of passengers that perished. This gives us 8.2% of all those that died had a first-class ticket. Then you can go and look at the crew and see that of all the passengers that died, 45.2% of those people were crew members. Now, because the first three rules of statistics are make a picture, make a picture, make a picture, those two tables will often be displayed better in some type of diagram. So, for example, here we have two pie charts which show the conditional distribution of class based on whether or not they survived or died. Note that the two pie charts are one-dimensional, so they are following the area principle, and that there's a key, so that way you know what each color represents. Another way to display conditional distribution is with a segmented bar chart. A segmented bar chart is the same thing as a pie chart, but it uses bars instead of circles. Each bar is treated as a whole, meaning that it has to go up to 100%. So anytime you make a segmented bar graph, your scale is going to end at 100%. Not before, not after. It does not matter if you count by tens or fives or twos, as long as you are consistent and that it is shown. Each segment of the bar corresponds to the percentage in each group. So here again we have the conditional distribution of ticket class based on whether or not they survived or died. So again, these are showing our row percentages, and each section corresponds to the percentage, in this case, of each class that died. So this would only be 8.2% here, whereas this makes up about 45% here. When you are comparing two distributions, you want to make sure that each piece is in the same order. So here we had crew member first, followed by third class tickets, then second class tickets, and then lastly first class tickets. So you want to make sure you follow the same order so you can easily compare them. You also need to make sure that you have a key when you are doing a segmented bar chart, so that way you know what each piece of the bar represents. Finally, we can use conditional distribution to describe what the data is telling us. So in our previous two diagrams and tables, we see that the distribution of class for the survivors is different from that of the non-survivors. Again, going back, we can see that far more people that were crew members died in the Titanic than survived in the Titanic. Same thing with third class ticket. Here we can see that the first class ticket, far less died than survived. This leads us to believe that class and survival are associated, that they are not independent. We don't ever really actually say not independent, so we would say that they are associated or have an association. For two variables to be considered independent, the distribution of one variable would have to be the same for all the categories in the other variable. So again, going back, in our segmented bar graph here, if these two variables were independent, so ticket class and survival had nothing to do with each other, each piece would be pretty much the same. We're going to talk more about association and independence tomorrow and a little bit later. So we're going to stop here right now, and I will see you guys tomorrow. Thank you.